Okay, this video is for the nth term test for divergence. Now, first thing to note, it doesn't say it's for convergence at all, and it isn't. So you can only use this test to say that a series diverges. If you want to say it converges, you have to switch to one of the other tests. The way this test works, it says, if the limit as n approaches infinity of your term does not equal 0, in other words, as you head out towards infinity to the tail end of all your terms, if you are not headed towards something very, very, very small, 0, then the series cannot possibly converge. So we would say that it diverges. So what they're saying here is if you keep adding things in out towards infinity, you're still adding in things because this is not headed towards 0. So they're fairly big. There's no way you're actually going to head towards a number. Now, it does not say that if it equals 0, it converges. And that's not necessarily true. In some cases it does converge, in some cases it diverges, but what that really means to you is you switch tests, you try something else. So for our first examples with this, it says determine whether the following series converge or diverge, justify your answers. So what I would do is actually just take the limit, and it's one of the first things you look for, because you should be fairly good at taking limits like this. So I'm looking at my a sub n, and I'm taking the limit as n approaches infinity. 2 times infinity plus 3 is infinity. 3 times infinity minus 5 is infinity. So I have infinity over infinity. It's an indeterminate form. I can use L'Hopital's rule, the derivative over the derivative. You can see that the derivative of 2n plus 3 with respect to n is 2. The derivative of 3n minus 5 is 3. This equals 2/3. If you couldn't use L'Hopital's, then you can use dominant terms. 2n is the dominant term in the numerator. 3n is the dominant term in the denominator. When you reduce those, you get down to 2/3. Just remember you can only use dominant terms when you're doing the limit as n approaches infinity. Now, what I actually care about is that this limit is 2/3, and the important thing is 2/3 is not equal to 0. So this series diverges by the nth term test. Okay, so we're going to look at different kinds of functions for the other example. So if I take the limit as n approaches infinity with something with factorials, I have n factorial over 2 times n factorial plus 1. I know that out towards infinity, this plus 1 isn't going to matter a lot. The n factorial and the 2 times n factorial are the dominant terms in this. And I'm going to choose to do dominant terms because I don't know the derivative of the n factorials. So I'm not going to be using L'Hopital's. So if I look at my dominant terms, my n factorials would cancel out, and this limit is equal to 1/2. And again, 1/2 is not equal to 0. So just like the previous series, we would write this series diverges by the nth term test. Another one to look at, with dominant terms, you have 3 to the n minus 2 over 3 to the n. So if I do the limit as n approaches infinity for this, that minus 2 in the numerator is not going to mean a lot out towards infinity. The dominant terms are right here, 3 to the n over 3 to the n. And what that reduces down to is 1, which is also not equal to 0, and that's what's important here. So both of these, well, all three of these series diverge by the nth term test.